All right, so think about this for a second. Like, trying to code without using the number zero. I mean, the entire concept of binary code, the very foundation of computers, and pretty much our whole digital world wouldn't even exist.
Yeah, it's kind of mind-blowing when you really stop to think about it, isn't it? This idea of nothingness, of a void. It's like it's so simple, yet so absolutely fundamental to everything.
Exactly, and that's precisely where we're headed today in our deep dive. We're going way back to explore the revolutionary origins of zero itself.
And what's truly fascinating is that this concept, something that feels so intuitive to us now, was once this radical departure from how people understood mathematics.
Totally. We're going all the way back to the 7th century CE to meet Brahmagupta, this extraordinary Indian mathematician and astronomer.
He wasn't just working with existing mathematical ideas, he was forging entirely new paths, especially when it came to this idea of zero.
Right, and to really get this, we'll be looking at historical accounts and analyses of his work, trying to grasp what the world of mathematics was like before zero was a thing, and then the huge ripple effects of his insights.
So our mission today is to understand just how significant Brahmagupta's contributions really were, particularly his work with zero and his pretty insightful astronomical theories, but also to appreciate the courage it took to challenge the established beliefs of his time.
Okay, so let's try to imagine a world without zero. It's like trying to breathe underwater or something, right?
Yeah.
I mean, what were the actual limitations people faced back then when it came to math? Imagine keeping track of large amounts of money or calculating trade routes without a way to represent nothing.
Yeah, if you try to connect that to the bigger picture, you quickly realize how unbelievably cumbersome even basic arithmetic would have been. Think about writing out the number 23 and then multiplying it by 105 without that zero as a placeholder.
Yeah, it'd be a nightmare.
Totally. And different systems used all sorts of symbols, abacuses, counting aids, and all that, which made complex calculations super slow and prone to errors, and really only accessible to a select few.
Right, it's like a specialized skill.
Exactly. And this really held back progress in fields that needed precise calculations, things like large-scale construction, accurate timekeeping, and obviously astronomy.
So it's like trying to navigate a modern city using a hand-drawn map from centuries ago. It's possible, but not very efficient. And then, boom, along comes Brahmagupta and makes this monumental leap. He declares that zero is a number in its own right, not just the absence of something. I mean, that's a huge philosophical shift. How do you even start to wrap your head around nothingness as something you can actually use in math?
Well, this is where things get really interesting because it makes you think about the nature of abstract thought. For Brahmagupta, and maybe drawing from existing Indian philosophical ideas about emptiness or void, zero wasn't simply a lack of something. It became its own entity, a fundamental part of the number system.
Wow. So he wasn't just throwing out a wild idea, he was actually developing a system around it. Which brings us to his big work, the Brahmasputa Siddhanta. What can you tell us about this text?
So Brahmasputa Siddhanta, which roughly translates to the opening of the universe, was a comprehensive work that Brahmagupta wrote when he was around 30 years old. And this wasn't just some narrow paper focused only on zero. It was this vast treatise covering a whole range of mathematical and astronomical topics that were known at the time.
So he was connecting a lot of dots.
Exactly. And what's really important to understand here is that this showcased how interconnected these fields were in Brahmagupta's thinking. And within this work, he systematically laid out the rules for arithmetic operations that involved zero, how to add it, subtract it, and crucially, how to multiply by zero.
The stuff we learned in elementary school.
Right. But back then, this was revolutionary, and it laid the groundwork for the algebra you might use in spreadsheets or coding today.
Didn't his exploration of dividing by zero cause a bit of a stir?
Yes. The famous, or maybe infamous, division by zero. Brahmagupta suggested that dividing a number by zero gives you infinity. Now, our modern understanding of math has refined this concept a bit, but the fact that he was even wrestling with such an abstract and paradoxical idea like what happens when you divide something into no parts shows just how intellectually curious he was and how willing he was to push the boundaries of mathematical thought. He wasn't afraid to explore uncharted territory, even if his initial conclusions weren't quite how we see them now.
He was a pioneer.
Right.
And he wasn't just focused on zero, right? He also formalized the use of negative numbers, which must have been another big conceptual leap for people back then.
Absolutely. Before Brahmagupta, negative numbers were used kind of implicitly, maybe in accounting or something, but he gave people clear rules for how they interacted with positive numbers and zero. In addition, subtraction, multiplication. And this inclusion of negative numbers essentially expanded the entire number system. It became a much more powerful and versatile tool for calculations and problem solving.
Okay, so he's rewriting the rules of arithmetic. But his curiosity didn't stop there. He also had some pretty radical ideas about astronomy that must have blown people's minds back then.
Yeah, you have to remember the prevailing understanding of the cosmos at the time. Brahmagupta's astronomical proposals were centuries ahead of their time. He proposed that the Earth was a sphere, and that objects fall towards its center. Basically, the concept of gravity.
And at a time when most people believed in a flat Earth.
Exactly. Imagine hearing that for the first time when everyone around you thinks the Earth is flat.
That must have taken some serious guts to stand up against such deeply held beliefs. What kind of opposition do you think he faced?
Oh, it would have been intense. You see, back then, cosmological views were often tied to religious and philosophical doctrines. So to suggest a spherical Earth and this force pulling everything towards the center, well, that challenged the very fabric of their understanding of the universe.
It's like telling people the sky is green.
Kinda. It took not only sharp observation and logic on Brahmagupta's part, but also a willingness to go against the grain. He risked being ridiculed and dismissed by everyone around him.
And this highlights something really important for us even today. The importance of questioning assumptions.
Yeah.
Even the ones that seem completely obvious.
Exactly. And what's amazing is that he was revolutionary in not just one, but two major fields.
A true polymath. And beyond zero and his earth-shattering astronomical insights, he also made other important contributions to math.
He did. Brahmagupta was incredibly productive. He developed formulas for solving quadratic equations, which you'll find in algebra and all sorts of scientific and engineering fields today. He also made significant contributions to geometry, including a formula for calculating the area of any cyclic quadrilateral. That's a four-sided shape where all corners touch a circle. And get this, he even came up with a remarkably accurate approximation of pi. You know, that constant we use for circles and spheres.
That's incredible. And wasn't he also a pioneer in trigonometry?
He was. He developed an interpolation formula for calculating sine values. And trigonometry, as you know, is crucial for astronomy navigation surveying. Brahmagupta's work in this area allowed for more precise measurements and predictions, which further advanced the scientific understanding of his time.
So all of these mathematical tools he was developing weren't just theoretical exercises. They had real-world applications, especially in his work on understanding the cosmos.
Exactly. He wasn't just playing with numbers. He successfully used his mathematical methods to predict the positions of planets and even to forecast eclipses with impressive accuracy for his time. This really showed how powerful his new mathematical framework was. He was bridging the gap between observation and calculation in a way that would have been incredible to witness.
It's amazing how much one person can accomplish. So how did Brahmagupta's work spread and influence the development of math and science in other parts of the world? How did it reach us today?
This is a key point. Brahmagupta's mathematical rules, including the concept of zero, laid the foundation for modern algebra. Centuries later, his work was translated into Arabic by Islamic scholars, and this was a pivotal moment. It allowed his ideas to spread throughout the Islamic world, where they were further developed and refined, and eventually these advancements, including the Indian numeral system and zero, made their way to Europe, shaping the trajectory of modern science and math as we know them today.
So without Brahmagupta's work, things would look very different for us.
Exactly. And this is a great reminder of how interconnected human knowledge truly is. How contributions from one part of the world can have a global impact for centuries. So think about this. What are the zeros in your own field or in your own life? Are there areas where definition is lacking? Where potential hasn't been explored simply because a fundamental concept or tool seems to be missing?
That's a great question. And what about those ideas that seem unconventional or even a little crazy at first? Brahmagupta faced a lot of skepticism, but he stuck with his ideas. What can we learn from that?
Well, he showed us the importance of resilience and the courage to challenge established norms. How often do we hold back from pursuing an idea or questioning an assumption just because it goes against conventional wisdom? His story encourages us to examine those hesitations and to recognize that real innovation often comes from venturing into the unknown, from daring to question the status quo, just like he did with the very concept of zero and the shape of the Earth.
Right, because sometimes the most groundbreaking discoveries come from exploring the seemingly empty spaces.
Yeah.
So to wrap up, Brahmagupta's definition of zero wasn't just a small tweak to math. It was a complete paradigm shift that opened up a world of possibilities, and it's still the bedrock of so much of our world today.
And his courage to challenge deeply held beliefs, not only in math, but also in our understanding of the universe, really paved the way for future scientific progress. It's a testament to the power of intellectual curiosity and perseverance.
So here's something to think about as we go. What seemingly small or even absent element in your own field or in a problem you're facing could hold the key to a new understanding or innovation if you were to really define it and explore it? Just like Brahmagupta did with zero. What zero are you on the verge of discovering?